Greetings, students. So today you've been working with transversals. Hopefully the Desmos activity helped to introduce you to the angles that are created by transversals. So what makes up a transversals? Well, first we have parallel lines. So in your notes here, you've got this definition. Hopefully you're familiar with parallel lines. There's two lines that lie in the same plane, but they will never cross each other. They have the same slope, remember, on the coordinate plane. Perpendicular lines, however, are lines that will intersect at 90-degree angles. So a transversal is a line that crosses through two or more other lines. So if you look at the drawing here, line T is a transversal that cuts through lines A and lines B. Okay, so a transversal is actually a line that cuts through two or more other lines. So our focus is going to be parallel lines cut by a transversal. So when we have a transversal that cuts through two parallel lines, we have angle relationships that we're going to be studying. The first type is corresponding angles. So angles that are basically in the same position. So for example, 1 is in the same position as 5. So actually, if I picked up 1, 2, 3, 4 and place them on top of 5, 6, 7, 8, we would have angles that sit right on top of others and they would actually be congruent. So for example, 1 and 5 are corresponding angles. They're in the same position. 2 and 6 are also corresponding. 3 and 7 and 4 and 8. These angles are also congruent, which means their measures are the same. Next, we have alternate interior angles. An alternate interior angle is an angle that's diagonally across from each other, and they're inside of the parallel lines. So for example, 3 and 6, they're inside of the parallel lines, but they are diagonal from each other. 4 and 5 have the same relationship. They are diagonal from each other, and they're inside of the parallel lines. Alternate exterior angles are also diagonal, but they are outside of the parallel lines. So for example, 1 and 8 and also 2 and 7. They are diagonal and they are outside of the parallel lines. The last one we're going to discuss is consecutive interior angles. Now we call these same side angles. They are inside the parallel lines, but this time they're on the same side instead of being diagonal. So 3 and 5 are consecutive interior angles, or you can call them same side. I tend to just say same side. 4 and 6 are also same side, and they're inside the parallel lines. There's a shortcut for determining angle relationships, and one thing that you can do is you can identify this pattern, and you start off by selecting any angle. Okay, I'm going to put a dot in angle number 1. Then you're going to go to the vertical angle. That's the angle directly across from it. So I'm going to put another dot on angle 4. 1 and 4 are called vertical angles. Now, if you repeat this pattern in the second set of angles below those, we can put a dot at 5 because it's in the same position as 1, and 8 is in the same position as 4. We have identified all of our obtuse angles. So those are our large angles, the big angles. Okay, so all of these are congruent. They all equal the same thing. If 1 is 112 degrees, 4 is also 112, 5 is 112, 8 is 112. Okay, so all of these angles are 112. Okay, and let me go ahead and mark those so you can remember that they're all the same. 112 and 112. Now, the other angles are called our acute angles. Those are the small angles. A linear pair are two angles right beside each other, and they form a line. So 1 and 2 form a line, which means we know they have to add up to 180 degrees. So we know that means that angle 2 has to be 68, because 112 plus 68 is equal to 180. So that means all the other angles, all the small angles, are all 68. 68. And if you just take a second and look at that, you will notice a pattern. And this pattern it works for all transversals. So students who understand and can identify this pattern, they find transversals very, very simple. Okay, so let's practice below. We're going to name the type of angles in each pair. So we'll start with 3 and 6. So here's 3 and here is 6. These angles are diagonal from each other, but they're also inside of the lines. Those lines aren't parallel, but it doesn't really matter. 6 and 3 are inside the lines, so those are alternate interior, and I'm going to just abbreviate that. Alternate interior angles. If you want to look back at the definition, you can do that. They are alternate because they're on opposite sides of the transversals, but they're inside of those two lines that the transversal crosses. Okay, and then 6 and 7. So let's look at 6 and 7. Got 6 and 7. Okay, these are on the same side of the transversal, but they're still inside of these lines right here. So 6 and 7, because they're on the same side, we're going to call them same side angles or consecutive. You can say same side or consecutive. Either one works. All right, let me erase this a bit. Okay, now 6 and 8. 6 and 8. We've got 6 here and we've got 8. Now these are in the same position, so we'll call these corresponding angles. That means they're in the same position. And by position, what I mean is that if you look at the 4 angles at the top, 6 is in the bottom right corner, Then if you go down to the 4 angles at the bottom, 8 is also in the bottom right corner. So 6 and 8 are in the same positions. So remember, those are called corresponding. And I'm going to abbreviate that as well. Okay? All right, so 1 and 5. Let's look at 1 and 5. 1 and 5 are right next to each other. So we've got 1 and we've got 5. And these angles create a line. They're called a linear pair because they form a line. And angles that are a linear pair, they will equal 180. If we add those two angles together, they equal 180. So we call them a linear pair. So 1 and 5 are a linear pair. And then 1 and 6. Get 1 and 6. This in red. 1 and 6 are vertical angles. They are directly across from each other. So 1 and 6, we call those vertical angles. Okay? So those are all the types of angles that you're going to see in a transversal or in angles that are created by transversals. Let's practice identifying angle measures based on these relationships that transversals create. So you want to start by labeling all the angles that you're given. So if you're given angle 5, which is this angle down below on the bottom half of this, we're going to label this 72. So there are other angles that we know have to be 72 as well. Like 8, since 8 is a vertical angle to 5, we know it also has to be 72. Okay? One thing I like to think about is that transversals create big angles and small angles. All the small angles are the same, all the big angles are the same. So we're labeling the small angles. So 1 is 72 because it's corresponding to 5. And because 4 is vertical to 1, it also is 72. Okay? Now we can go back and label the big angles. Since 1 and 2 are a linear pair, we know that if we subtract 72 from 180, we should get the measure for angle 2. So 180 minus 72 is 108. So all the big angles should be 108. So 6 is corresponding to 2, and 6 is vertical from 7. And then 3 and 7 are both corresponding. Okay, so hopefully you see that pattern. And then you're going to go over here and just write all your angles. Okay, so 72 for angle 1. Angle 3 is 108. Angle 6 is 108. Angle 8 is 72. Angle 2 is 108. Angle 4 is 72. And angle 7 is 108. Okay? So, again, all the angles should be one of two measures, either the measure of the small angles or the measure of the big angles. Okay? Lines J and L are parallel. Use the given information to answer each question. So, if angle M, now be careful with this because these are all conditional. It's saying if angle 2, it's not saying that it is, but if angle 2 is 117 degrees, find angle 7. So you first have to identify the relationship. Well, angle 2 is an alternate interior angle with 7. So 2 and 7 are alternate interior angles. They're diagonal from each other, and they're inside of the parallel lines. So they're alternate interior, which means they are congruent. So that means if angle 2 is 117, the measure of angle 7 is also 117. Okay, now let's look at angle 3. Angle 3 is down at the bottom. So we have angle 3 here, and then it's asking us to find the measure of angle 8. So angle 3 and 8 are vertical angles, which means they are congruent. So if angle 3 is 31, the measure of angle 8 is also 31. The measure of angle 7 is 120. So here is 7. And then it's asking us to find measure of angle 6. So if we look at 6 and 7, they're same side. Now, same side angles on the inside of those parallel lines, these are linear pairs, or they're not linear pairs because they don't form a line, but they are what we call supplementary, which means they should add up to be 180. So like in that example at the top when we had angles that were 72 and 108, any angle that's 72 and any angle that's 108 adds up to 180, so they're supplementary. So if 7 is 120, we subtract that from 180 to find angle 6, and that would be, 60, because they would have to add up to 180. Supplementary angles have to add up to 180. So we've got angle 4 is 101. If angle 4 is 101, what is angle 2? If we look at that relationship, they are corresponding. They're in the same position, which means they are congruent. So if angle 4 is 101, angle 2 is 101. Angle 6 is 23. Angle 5 is a linear pair. So 6 and 5 are linear pairs. That means they add up to 180. So we subtract 23 from 180. Let's see, we get 157. So 157 would be angle 5. If angle 3 is 54, it says to find angle 2. So these are same side, so they're also supplementary, which means they add up to 180. So we would subtract 54 from 180, and we would get 126. Okay? So, guys, just review this. Look over these notes. Make sure that you put these notes in your binders because, again, you will be able to use them on the test. And hopefully this helps. Make sure that you do the practice work that is assigned in Google Classroom. Enjoy the rest of your day.